So we got a bunch of requests to show a little bit about the terrain generator that we made for we were just messing around with Unity, trying to get a 2D terrain going. And we decided to make a quick video here. So this isn't going to be too code heavy. It's going to be more about the concepts that we tried and what actually worked and what didn't work. The idea is that this is for a mobile game. So the target device was going to be iPod 2 Plus. So we wanted 30 frames per second on the iPod 2 and 60 frames per second on the rest of the devices. That was kind of the target benchmark for what we were doing here. So before we get into anything, let's just have a quick look at what's happening here. And I'm going to hit play. So what you'll see in the scene view is we have a terrain. This is all dynamically generated. And you can see that we have a second camera here. So while you're playing, it's just a zoomed out version of the first camera, so you can kind of see what's happening with the terrain. And we tried a whole bunch of different things, and we'll tell you what worked and what didn't work as we go along. But the general idea is that as you move along, once you get to a certain point, we get a new terrain generated here. And you can see as it goes along, it just keeps regenerating. And what that's doing is just we're using two meshes that are generated on the fly. And it's adding a mesh collider as it goes, which you can see there. And this is a fully configurable terrain. So in this particular case, we're looking at retina resolution because we're on the 4G wide. So it'll actually choose smaller segments because it can handle a bit more. If let's just continue on so you can see what it does here. So as we're playing, it's generating the mesh, and you can on the fly start changing different values. Like for instance, if you wanted a more of a tiny wings kind of look and feel for the terrain, you just up the values, and you'll see that the hills will start to get a little bit more jagged on there. And we'll just mess with this a little more. So kick these up a bit. So as the terrain gets generated, so now we're generating some steeper hills in there. And just to show something different, if we drop the range of the X, so what that's doing is basically spreading out when the hills get generated. So once we spread those out, let me just jump up so it zooms, you'll be able to see, and let's drop the hill height. And once the next mesh generates, it's going to have the new settings. So they won't take effect on the current settings, but they will take effect on the next generated mesh. So let's spread these out a little bit. Our Y is a little bit too bumpy, so now we can see up here we're starting to get smoother curves. So let's say we wanted to have an incline section. We could raise the incline up, and on the fly the next mesh will actually start to incline once it generates here. So there we go. So now we're starting to go up. And same thing for decline. If you wanted to go down, you can just kick that down a bit. We'll drop our hill size so it's a little too big. And once that next mesh generates, we're going to start going down. And the segment width can also be changed on the fly. So if you had a little bit more processing power, you can crank it up. If you had less, you can drop it down. So you can see with the segment width of 120, we're now, let's flatten this terrain out a little bit so we can see it. Let's jump that all the way up so you can see we're getting real bumpy terrain now. It's not very smooth. But we can crank this all the way down to say 5, which is probably a bit much even for desktop, and you can see how much smoother we're getting this. Alright, so that's the main gist of what's happening here. Obviously there was not much going on there in the realm of controls and graphics. So let's hop in and see how this is all done. So the first thing we do is set up a camera, just using all the basic rules, using an orthographic size at half the screen height, which gives us pixel perfect at a zoom level of 1. So at our standard zoom level, we'll be pixel perfect. And that's the main idea here, is we want this to look good on everything from a iPad 3 Retina to an iPhone 3GS or iPod 2. So the TerrainManager is where all the neat stuff happens. So you can see on this, there's just a game object here, and it's just the TerrainManager has a physics material and a material, and that's all there is to it. So this object is basically what what controls the terrain and how it works. So first off, we just set a texture based on if we're HD or not, and we create a new terrain. And again, the terrain, so there's going to be 3 classes involved with this. The TerrainManager will handle telling the terrain when to actually generate. The terrain class will actually handle the generation of the mesh. And then we'll have a TerrainGenerator, which is a data-only class that just spits out values. And nothing else here is really too important. We make 2 GameObjects, stick a mesh filter on each one, and set smooth sphere collisions to true. And the reason we did that is we found that with PhysX, the only way to get anything close to performant on a mobile device was to only use spheres and for collision and to set smooth sphere collisions. We tried a bunch of various things like laying out box colliders, tried just leaving this as is, but when it came down to it, we found that using a sphere and just manually adding in any drag that we wanted to or any other forces, so we just do everything from there to get a good feel manually, and we let PhysX only handle the sphere collisions. So in update, what we have here is it's just doing a check to see once the camera is close enough to the right side of the screen that we're gonna need a new mesh. It'll swap meshes. So, we only have 2 mesh objects. We created up here. We only created 2 meshes. This could be extended to have 3 or 4 if you needed to be able to go left and right, for example. But in this case, we only needed 2, and it was the most efficient. So we swap our actual terrain game object, and then we tell the terrain generate a mesh, and we give it the mesh filter to generate it with. So the terrain itself, this terrain object, is kind of like more of a dumb class. It just gets fed a mesh filter and it'll just stick a terrain on there. It doesn't have any knowledge of if the terrain's visible or not or what's happening with it. So let's have a quick look in there. So this object is actually just a standard class, not a Monobehaviour. And it is, if you remember, we're calling generate mesh with width. So let's have a look at this. So basically what this is first doing is it's going to try and figure out where it needs to start generating the mesh. And it'll just loop through and figure out start I, basically a start index and an end index. And it's getting those values from the TerrainGenerator. The TerrainGenerator is actually kind of a neat little class. So let's have a look in that since we're here. So the TerrainGenerator, and you'll notice it's actually IEnumerable. And that's an important piece of this. So what this lets us do is we can swap in different terrain generators if we want. So as long as it's it can spit out values, we can maybe if we wanted something a little bit boxier, or if we wanted to be able to make caves or overhangs, like this specific generator will just do a cosine curve, and it has various properties that you can modify, like you saw with the sliders, where you can change the heights and the the ranges and whatnot. And what this basically does, and the reason why we used IEnumerable here, is so we override the square brackets operator, and this lets the TerrainGenerator, you can just pass it an index, and if the index is past the point that it has that it's generated points for, it'll just actually create a few more points on the fly. So you can always just hit the index with whatever you want, and it'll generate values to fill in. So say you're at index of 1. If you ask for an index of 10, it'll fill these in for you and then provide you with the index you asked for. And that's the main reason why we used IEnumerable. So you can see in here what we did is it has an internal enumerator that it uses for all this. And let's have a look at that so we can see it. So the internal enumerator is it's basically enumerator is just an interface that you can pop on something that requires you to have 2 methods. You need a getEnumerator method, which is extremely basic, and this is the actual function where the magic happens. So we have this enumerator here, and the TerrainGenerator keeps a handle to the enumerator. Grab that in the beginning. If you see here, it keeps an internal enumerator. And that's how every single time it needs a new value. All it has to do, and this is locked into a while loop here, and we do a yield return. So all it has to do is ask for one, and this is going to maintain state for us. So this way, like if we ask for index of 20, this one knows what index 19 is and where it ended. So when it creates the 20th index, it's going to match up properly. And it's just a neat little trick in there. So this is generating what we call key points. And the key points are going to be pretty boxy. So this is a pretty basic little algorithm here, and this has nothing to do with the actual curve. All this is going to do is generate points, and it'll end up being kind of like straight lines, like in this. If you could see the mouse cursor going, it'll have it'll only contain the bottom and then the top and then the bottom and the top. So it generates a really rough outline of what we actually want, and we fill that in later on. It's not really that important for this section of things. We don't need to store all those values, so we only store our key points, which is our peak and our valley. And besides that, this has just one other little method that's handy. So we can reset to last used index, and what this does is it just cleans up values, so we can go endlessly. So once if we reset it to say mesh 1 ended up at 100, an index of 100. So once we go on to mesh 2, we can reset this and wipe out all the old values. And this will just it'll save the last couple values here. You can see that we in this little loop here, we shift some of the values so that they start at 0 again. This way each mesh can start asking for an index of 0, and it's still going to line up properly. Okay, so onto the terrain. So now we know how the generator works. So when we generate the mesh, we reset it, and then this allows us to use 0 indexes, and we loop through and we generate just enough key points to fit the width. So once we've generated our key points, we can draw the mesh. And draw a mesh over here. It's not going to go into too much detail, but what it basically does is it's going to store the border verts, and border verts are all of the vertices on the top. So they're going to be the verts that actually define the curve. So if we look at an actual terrain here, we can see our border verts are going to be just the ones up here on the top, and only we have a mesh where we're generating some more over here, but we're only concerned with this row here. That's all the data we need for this, and that'll allow us to put trees or lock different objects onto the landscape at runtime, and it also allows us to, it's enough information for us to generate this mesh, the mesh used for collision, that is. Okay, so we save out our border verts, everything else is throwaway, and we basically are just going to loop through our key points. So if you remember, our key points were they were jagged, they were just the peaks and the valleys. And first we figure out how many segments we need, and then we loop through the segments, and we actually just use a cosine curve here to generate a smooth curve in there. So in a case like, let's drop this in size. Okay, so we can see a bit more. So yeah, it's something else. When you drop down to a different resolution, we have different textures in here just for testing. And as we mentioned before, it always remains pixel perfect. So this was just in here for testing different things to make sure that something even with this kind of noise would be tiling properly. Okay, so what I was saying, so our key points would be, in this case, something like this. One of these points up here would be a key point, then this one, then this one. So they'd be really jagged if we use them directly. So that's why we use a cosine curve to fill in the values. So we would use, you can set an actual segment width, and that'll define how smooth the curve is. And in this case it's 20, so it'll just loop through and it'll create points every 20 unity units. And that can be varied on the fly again for different devices, and that lets you have that nice smooth curve. So once we've generated a mesh, we create the triangles, of course, stick that on there, recalculate bounds, and then we add a mesh collider. So the mesh collider, like I mentioned before, all it needs to know is the border verts, because the mesh collider is not really concerned with much else. It just needs to make a platform so that the player doesn't fall through. So what we do here is just loop through the border verts, create a mesh on the fly. Once we have that mesh, we stick the verts and the tries in there, and then we stick it on the mesh collider. And that is really all there is to it. So this right here, we have it set to 60 frames per second. It's not going to get 60 while doing screen recording most of the time, but even on an iPod Touch 2, it'll hit 30 frames per second. Every other device, iPad 1, 3GS, they'll all be locked at 60 frames per second with terrain generation. All right, so that's the things that we used in here and what ended up working for us to get 2D terrain with dynamic generation. Thanks for watching.